Hello students, how are you all? I hope you all are doing well. So as you know, we have completed the oscillation and wave motion series. Next we will discuss about interference. So what we are going to discuss here in the first video of interference. In interference, in this lecture series number 1, we will discuss about what is interference, what are the different types of interference, what are the conditions of interference, and you must have seen it is written here Young's double slit experiment, which is known as the division of wavefront. We are going to discuss all these things in this series. So let's start the series. So here you can see the definition of interference is written. So you know that superposition of wave already we know. Superposition means when two or more than two waves travel simultaneously at a single point. Then the resultant displacement. The resultant displacement, how to calculate? Now if we calculate, if y is the resultant, if y1, y2, y3, these are the displacements of first, second, third wave traveling simultaneously across a single point. Then that point have resultant displacement y, which is nothing but y1 plus y2 plus y3. So depending upon different conditions, we have divided superposition into different category. As you must have studied that one is interference, one is beats, another one is standing waves or stationary waves. But as here we are going to discuss about only interference. So definition of interference is written here. And so what is interference then? Now when two waves traveling along same direction with same frequency, this is important case. Frequency must be same. Two waves traveling along same direction with same frequency, having same or nearly same amplitude, it is not that much of bound, superpose on each other. Their resultant or the superposition result is said to be interference. Again I am repeating, when two waves traveling along same direction with same speed, having same frequency, this is very important, frequency must be same, superpose on each other or overlapping takes place, their resultant is said to be interference. Again, we have divided interference into two categories. One is constructive interference, one is destructive interference. So let's understand what is constructive, what is destructive. Here you can see written the constructive case. So constructive means what? If we consider two waves and the superposition takes place in such a manner that trough of one wave coincides with trough of another and crest of one wave coincides with crest of another, that is like to like coincide, like to like overlapping, trough to trough, crest to crest. This type of interference is known as constructive interference. So let's understand that. So if we draw, for example, we have two waves. One wave starts from here. This is the first wave. And we have another wave. If the wave starts from here, then you can see trough to trough and crest to crest overlapping takes place. Trough to trough, crest to crest overlapping. Amplitude may or may not have same as that of the first wave. So this type of case is known as constructive. If the amplitude of first wave is A and amplitude of second wave is B, then here you can see, we know that this is the axis, in upward we say positive, in downward of that is said to be negative polarity. So the result will be, Y will be A plus B, or resultant amplitude is always A plus B. So result we will get like this. Since the resultant is more than A and B, this is said to be constructive. And in constructive case what happens, since amplitude increases, and as we know that intensity is directly proportional to square of the amplitude, so intensity will also increase here. This is said to be the maxima condition or maximum intensity condition. So if A and B are the amplitude of first wave and second wave which superpose or overlap constructively, then the resultant will be in the form of A plus B amplitude, and the intensity, maximum intensity, is directly proportional to A plus B square because of square of the amplitude. Clear? And there is a condition you can see. The condition states that path difference must be equal to an even multiple of lambda by 2. Even multiple you can see. For constructive interference, path difference must be an even multiple of lambda by 2. Hope you understand constructive interference. Next we will go to destructive interference. So destructive means completely opposite one, where destruction takes place. That means the amplitude decreases, the intensity also decreases. So this will happen when draw of one wave coincides with crest of other, or vice versa. That means opposite manner overlapping. One positive side, one negative side. This is said to be destructive interference. If the first wave is like this, where amplitude is A, and another wave is there which is destructively overlap takes place, B, then you can see both are in opposite direction. So this is A, this is B. So their resultant will be like this. This is the resultant. Let we mention resultant as Y. So the resultant amplitude will be A minus B. Since amplitude decreases and intensity is directly proportional to square of the amplitude, so intensity also decreases in case of destructive interference. So the resultant intensity minimum, because of decreasing, so it will be minimum, will be directly proportional to A minus B square. In constructive interference, we know that path difference must be even multiple of lambda by 2. So this will be opposite. So the path difference will be odd multiple of lambda by 2. You can see odd multiple, n plus half or 2n plus 1 lambda by 2. Directly you can also write down. So this must be odd multiple of lambda by 2. So again I am repeating what is constructive, what is destructive. So by comparison method you can easily remember, constructive means when trough to trough, crest to crest overlap takes place. Destructive means the opposite, when trough of one wave coincides with crest of other, opposite manner. So in constructive case, since similar type of overlapping takes place, the resultant amplitude increases. In destructive case, resultant amplitude decreases. And we know that intensity is directly proportional to amplitude square. So intensity in constructive will increase, so it will be maximum. Intensity in destructive will decrease, so it will be minimum. Clear? And one more condition is the path difference. So path difference must be odd multiple of lambda by 2 here in destructive case, and in constructive path difference must be even multiple of lambda by 2. I hope you understand. If you have any question related to interference, constructive and destructive interference, you can let me know in the comment section. Then we will discuss about the conditions. So the conditions are the two sources must have same frequency. Two sources must have same frequency. And one more important thing is here, which is said to be coherent. So coherent means what? That both the source must have a constant phase difference throughout the motion, or throughout the overlapping, throughout the superposition. Both waves must have a constant phase difference. It may be 0, maybe pi by 2, maybe pi by 5, maybe pi by 4, maybe pi, whatever the phase difference may be, it must remain same throughout the motion. Clear my point? So we understand that, and two sources should be narrow and close to each other. We understand that for maxima, intensity is directly proportional to A plus B square, and for minima or destructive, intensity is directly proportional to A minus B square. Remember this formula, you will get numericals regarding to this formula. So next we will discuss about Young's double slit experiment. Young's double slit experiment is an experimental setup in order to study the interference pattern. So this is also said to be division of wavefront, because here we are considering a single source, and from the source we are creating two slits which are appears to be two virtual sources. Since we divide the same wavefront into two parts, this is said to be division of wavefront. Let's start this one. So here you can see this is the construction where we consider a source S which emits lights of wavelength let lambda, and we put two slits S1 and S2 which are at a distance small d apart. So remember, small d is here distance of separation between S1 and S2, which are the two slits which appears to be virtual sources. And in order to observe the interference pattern, we put a screen at a distance capital D. Capital D is the distance of separation of the screen from the slits, where we have to find out interference pattern. And O is the midpoint of the screen, and A and B are the corresponding points parallel to S1 and S2. And we consider an arbitrary point P, which is at a distance Y from the center O of the screen, where our aim is to find out interference pattern. So if total distance, here you can see total distance is D, so half of this will be D by 2, this is just written D by 2. Now our aim is to calculate the interference pattern. So as you know, we already discussed that interference we have to calculate by considering the path difference, because we have the condition for constructive path difference must be even multiple of lambda by 2, for destructive path difference must be odd multiple of lambda by 2. So first we have to find out if two beam of light, one starts from S1 reaches P, another beam of light starts from S2 reaches P. So there will be interference between light traveling from S1 to P and light traveling from S2 to P. So we have to first find out the path difference. So what is path difference here then? Path difference we mention as x. So path difference is the distance difference. So from figure we know that S2 to P1 light is traveling and S1 to P also another light is traveling. Obviously the difference between them is nothing but the path difference. So we have to first calculate S2P minus S1P. So you can see in the triangle S2BP here, S2B, this is 90 degree and this is P. Then we know that H square equal to P square plus B square. We have to use that formula. P square equal to H2B square, base and perpendicular, P B square. This is just H square equal to P square plus B square formula. But from figure you can see what is S to B. S2 to distance B is nothing but capital D. So you can write D square. And what is P to B? P, this point to this point. P to O up to this distance is Y. And from O to B is D by 2. So this distance will be Y plus D by 2. Again I am repeating, you can see we have to find out distance from P point to B point. But from figure we have the formula, we have the distance P to O as Y and O to B as D by 2. So this will be Y plus D by 2 square. Now we have to rearrange it. So we get S2P square equal to capital D square plus Y plus D by 2 square. If we take D square common, then this will be 1 plus Y plus D by 2 whole square divided by capital D square. And this is S2P square, but our need is S2P, so you can take square root. If we take square root on right hand side, this will be capital D, and here it will be square root term 1 plus Y plus D by 2 whole square divided by capital D square power 1 by 2. I think you remember binomial theorem. Binomial theorem, 1 plus x to the power n must be equal to 1 plus nx when the condition is x is much less than 1. Here the second term, this term is very less as compared to 1, because you can see y is a very small quantity, d is small quantity, so d by 2 again another small quantity, and so if you take square of that, obviously it will be another small quantity, because if we take 0.05 or normally if we take 0.1, its square will be 0.01, the value decreases. Again we have divided d square, d is a larger quantity, so if this whole term is less than 1, for that reason we are going to use this formula. See here then, if we use that formula, then we will have S2P will be capital D, in bracket we will have 1 plus Y plus D by 2 whole square divided by d square, and we have to multiply this 1 by 2 in the second term. So if you multiply, this will be like this, 1 by 2, or 2 directly you can write here. This power we have multiplied here because 1 plus nx. Now if you multiply capital D here, this will be capital D, S2P will be capital D plus y plus d by 2 square divided by 2d. So this is the expression for S2 to P. Similarly, we can calculate S1P. So you can see the figure. S2 to P we have calculated, where we consider the distance capital D, and this is y plus d by 2. And when we calculate S1 to P distance, we have to use the distance P to A. So this is nothing but y, this whole distance y, this is d by 2, this will be y minus d by 2. So no need to derive again, you can directly use this trick to calculate or to write S1P. So S1P will be capital D plus y minus d by 2 here divided by 2d. Now we have S1P and S2P formula. Our aim is to calculate this path difference. We have to calculate path difference. So path difference is nothing but S2P minus S1P. We have to just subtract. Now we have the condition for S2P and S1P. We have to subtract. So path difference equal to S2P minus S1P. So x equal to S2P minus S1P. S2P is D plus y plus d by 2 whole square divided by capital 2D minus d minus y minus d by 2 whole square divided by 2D. Here you can see these two formula, y plus d plus d, y plus d by 2 whole square by 2d, similarly y minus d by 2 by 2d. We can cancel capital D here. We can cancel capital D. Then x will be here. We can take common 1 by 2d. In bracket we will have y plus d by 2 whole square minus y minus d by 2 whole square. And this is nothing but a plus b whole square minus a minus b whole square, which is equal to 4a into b. So 4ab means 2 you can cancel here. 2 we can cancel, 2, 4, 2. So the result is y small d by capital D. So we get the path difference x equal to y small d by capital D. This is the expression for path difference between the ray of light traveling from S1 to P and S2 to P. From figure you can see light travels from S1 to P, light travels from S2 to P. So the x we have calculated is nothing but the path difference between them. But we know that path difference conditions we have. For constructive it must be even multiple of lambda by 2. For destructive it must be odd multiple of lambda by 2. So now we have to use those conditions. For constructive interference, x must be even multiple of lambda by 2, which is equal to n lambda. So you can use the formula here. Already we get the formula for x. So y small d by capital D equal to n lambda, or y equal to n lambda capital D by small d. This is the position. This gives us the position for constructive interference points, or you can say the bright points. Clear? Where n equal to 0, 1, 2, 3 and so on. Now we have to use the condition for destructive interference. So for destructive interference, we know that x must be equal to odd multiple of lambda by 2. So path difference is y small d by capital D, 2n plus 1 lambda by 2. So y equal to, you have to just cross multiply, 2n plus 1 lambda capital D by 2d. Same thing, n equal to 0, 1, 2, 3 and so on. So if you write 2n minus 1, then you have to start n from 1. If you write 2n plus 1, you have to start from 0. So this gives us the condition or the positions for all the dark points. And in the previous slide, here we get the conditions for bright point. In Young's double slit experiment, we get the dark fringes and bright fringes in alternate way. So the distance between any two consecutive dark points or any two consecutive bright points is known as fringe width. Fringe width is written by or denoted by beta. The distance between any two consecutive dark points or bright points is known as fringe width, which is denoted by the symbol beta. So let's calculate what will be the expression for beta here. So beta equal to y n plus 1 consecutive, so n plus 1 minus y n. We can calculate for dark point, we can calculate for bright point. So let's calculate for bright point first. So in bright, this is y n, n means nth point, so this will be n lambda capital D by small d. So for n plus 1, it will be n plus 1 lambda capital D by small d, and n will be n lambda capital D by small d. So in both, from both term we can take common lambda capital D by small d, and in bracket we will have n plus 1 minus n, so this is 1. So this will be the expressions for fringe width. Fringe width. So we get the expressions for fringe width as lambda capital D by small d. Clear? I hope you understand about fringe width. So I used here the expression for bright points or constructive points. Now your work is to calculate the fringe width for dark points, and let me know in the comment section what result you are getting and whether the fringe width is same as that of we calculated for bright points or it is different. In the next video, I will give you some numericals to practice. Thank you.